ISET is a software package developed by ImageVal Consulting. It was designed to enable you to measure and visualize how changes in image systems, hardware, and algorithms influence the quality of the image. The software allows you to specify and explore the influence of physical properties of visual scenes, imaging optics, sensory electronics, image processing algorithms, and displays on image quality. The ISET software is organized into four main parts corresponding to the four stages in the imaging pipeline. These are the scene, the optics, the sensor, and the processor. The user creates and manipulates the objects and algorithms that transform the scene into an optical image at the sensor, the optical image into a sensor image, and the sensor image into a set of digital values for display. In this video, we introduce ISET by using the Graphical User Interface. The ISET Graphical User Interface consists of a suite of integrated windows that allow the user to view and alter the key physical objects in the image systems pipeline. Again, these are the scene, the optics, the sensor, and the processor. Another way to use ISET is to write MATLAB scripts that call ISET functions. ISET is a collection of open source MATLAB routines, so you can see, copy, and edit the functions. You can find out more information about ISET functions on our website, or by selecting the Help menu using the Graphical User Interface. The purpose of this video is to introduce you to ISET using the Graphical User Interface. Before we begin, you should have already installed ISET. If you have not done this, you can find installation instructions on our website. We launch ISET by typing ISET in the MATLAB command window. If this is the first time that you launch ISET, you will receive a message indicating that there is no ISET session file. ISET will then create a session file and store it on your working directory. The session file is an integrated record of the scene, optic, sensor, and processor objects and their properties. It stores the data created and analyzed during the program execution. When you initiate an ISET session, a main ISET window appears that allows you to access each of the principal object windows used to create and manipulate data. The four buttons in the window are ordered to follow the imaging pipeline. Data begin in the scene, pass through the optics, are captured by the sensor, and transformed by the processor to yield a final display image. Before we review the functions of each object window, I'd like to point out some of the features that are common to all object windows. ISET windows have the same basic structure. The windows controlling each of the objects are organized by a set of pull-down menus and editable boxes. The pull-down menus in all of the object windows are organized in a similar, familiar way. They all have file menus to load and save object data. They have edit menus to adjust the properties of the objects, plot menus to plot object data, an object menu labeled appropriately scene, optics, sensor, or processor, depending on the window. This menu is used to select and create object properties. And finally, an Analyze menu that contains methods and metrics for analyzing the quality of the object. Here is the File menu that allows users to load and save data. The Edit menu that allows users to delete, rename, or edit the properties of the objects associated with that window. The Plot menu enables the user to plot data associated with the object. For example, the user can select and plot the radiance of any area in the scene window. And similarly, the spectral power in a section of the irradiance image. The user can plot the spectral data for filters and sensors used in the current sensor window. and the data characterizing the display properties associated with the current processor window. The scene window has a pull-down menu to load in a variety of different scenes. The optics window has a menu for selecting optical parameters for standard optical formats as well as customized information from calibration or lens design software. The sensor window has a menu to change parameters of the sensor, such as a color filter array, photodetector, quantum efficiency, infrared filters, and so on. And finally, the processor window has a menu for loading display parameters, such as the spectral power distribution of color channels, and the spatial layout of pixels, the display gamma, and so on. Finally, the Analyze window lets users calculate measurements and metrics. So here I'm showing an example of plotting the CIE coordinates for a region in the scene. And here is an example of plotting the lens point spread function for 400 nanometers. This is a plot of the irradiance of a single pixel at 400 nanometers. We can plot the point spread functions for other wavelengths as well. There are a variety of different metrics that we can calculate to analyze the sensor. Here are some examples, and let's look at the pixel SNR, and here we show the parts of the total pixel SNR shown in black that are determined by shot noise at very high low levels and at read noise, which is determining total SNR at low light levels. Let's now plot the sensor SNR, which is additional noise components. And so we can see here, when we look at the sensor SNR, the total SNR is limited by dark signal non-uniformity at low light levels and photoreceptor non-uniformity at high light levels. Now, there are a variety of different metrics that we can calculate to analyze the image quality of the processed image. Here are shown some. Let's look at an example where we analyze the color accuracy based on the Macbeth color checker. And since this image has not been color balanced, we would expect the color accuracy to be quite poor. And this is in fact what we see. We see a mean delta E of 20, which is quite large. We would expect this value to go down, have better color accuracy when we analyze the color balanced image. Well, this ends part 1 of our introduction to the ISET graphical user interface. Part 2 continues this tour by introducing the properties of each of the ISET objects in more detail.